The traditional way of checking the network coverage was by having people drive around with the test devices and other many tools to assess the real-world quality of the signal received at different locations. As you can guess, this is time-consuming and expensive. Many years back, at a sound conference, I recall hearing a Deutsche Telekom speaker who said that they can save 40% operational expenses by using various sound solutions, minimization of drive testing or MDT being a big part of that. When we looked at the TCO tutorial, we discussed that drive testing forms a good part of operational expenses or OPEX. While in this chart, we show drive testing as part of manpower, the results have to be generally processed manually, which forms part of operations. There are already tools available that can process the results automatically with very little human intervention, but it is still some way to go before they are completely autonomous. As mentioned, drive testing is one of the biggest costs of running the network after the energy usage. In a traditional network, drive tests must be done multiple times on different network loads to get an accurate picture of the cell's coverage and capacity. We have to remember here that the vegetation changes with seasons, so drive tests have to be done throughout the year. To reduce the amount of drive test, MDT feature was introduced in release 10. Two types of MDT have been defined, immediate MDT and logged MDT. Finally, MDT measurements can be on control plane or user plane. Let's look at what we mean by user plane and control plane MDT. The user plane approach works with the operator deploying or asking user to deploy some application. Once they do that, then the application continuously or regularly runs and collects a log and other information. This approach would be specific to an operator or a vendor. In the control plane based approach, the network would use 3GPP based signaling and messages. This approach would be the same across all devices and networks. Having said that, each vendor will use their own set of messages and sequence of messages to optimize the network. Let's now look at what is meant by logged versus immediate MDT. Logged MDT is used in case the UE is in idle mode. When the UE is connected to the network can inform the UE to log measurements. The UE logs the measurements while in idle mode. When the UE connects to the network again, it informs the network if the logs are available. The network can then retrieve them. This feature is optional for the UE to support. Immediate MDT is, as the name implies, immediate reporting of the failure. When the UE is in connected mode and has a radio link failure, it collects the logs and indicates to the network that the RL failure logs are available for the network to retrieve whenever it wants. This type of reporting is mandatory for the UE to support. Let's start with the logged MDT example. You have to remember here that in idle mode, there is no signaling to the UE. So what happens is that when the UE is in RRC connected state, the network sends logged measurement configuration message to the UE to configure it for logged measurements as soon as it enters RRC idle mode. Once in the idle mode, the UE takes measurements which is in multiples of DRX cycle. It then stores the downlink RSRP or RSRQ in the log along with timestamps and any location data that it has available. When the UE next establishes an RRC connection, it can signal the availability of its measurement log using a field in the message RRC connection setup complete. The network can then retrieve the logged measurements from the UE using the UE information procedure and can forward them to the management system. It should be noted that all these extra measurements shouldn't drain the battery of the UE. so the network should only configure the normal amount of measurements. Immediate measurement is configured when the UE is in RRC connected state. On specified measurement occasions, the UE keeps on measuring the downlink RSRP or RSRQ. When the UE encounters a radio link failure due to coverage hole, it logs the signal strength and the location information. After the completion of successful RRC re-establishment procedure, the UE indicates the availability of the log in RRC connection re-establishment complete message. The network can then retrieve the log at a convenient time. If the network is not interested in the log information, the UE can discard the information 48 hours after the radio link failure was detected. This is the typical procedure of collecting the RLF information by OAM or SON server. We have looked at this earlier in other scenarios. It's the same approach using the UE information request and response messages. You can see the contents of RRC UE information request message here. The network can request multiple information as part of single message. You can see the contents of UE information response message. The RLF report R9 contains a small amount of information in 3GPP release 9. In release 10 and 11, it has been extended further to provide much more detailed information for MDT scenario. If you are interested in exploring further, the best way is to pick up RRC specification 36.331 and look for message contents in section 6 of the specs. Let's briefly have a look at MDT enhancements in release 11. MDT was enhanced for release 11 to collect not only measurements indicating the network coverage condition, but also those indicating the user's real-life throughput and connectivity issues. For most cases, the battery consumption is not significantly impacted by MDT. One exception is that the ability to request the UE to activate its GNSS receiver for MDT that has been introduced in release 11, which is expected to involve significant battery power consumption. The operator may choose to handle this by subscription agreements and only use requested location for subscribers that have consented to this. Here are the references for further reading. The first few links have more details on MDT, so please do check them out. The slides are available on our SlideShare channel. This was minimization of drive testing in brief. It is a very powerful feature, but it has not yet been deployed with great success. There is still some work to be done, especially with 5G and multi-rat networks. We will now look at cell outage detection and compensation. Thank you for watching and goodbye.